I hope.
All right, we're live.
Really, we're live.
The stage is yours.
Awesome. So I got 30 minutes roughly, right?
Yeah.
Okay.
Roughly.
Yeah, roughly. Okay. Yeah, everybody here in the crowd, but also online. So hi, Elke, hi, Stefan, Fabian, hi, the other Prof. Yeah, I'm Wolle, and I'm super excited to be here in my, I think, first public live stream, actually. And the topic today of my talk is data validation at scale, and the subtitle is already giving it away. It's about managing data quality in complex data pipelines. You got all the material online at wolle.science, so you have the slides and later the video there if you're interested. And also you can get the slides more right. You can get the slides here right now, like wolle.science/data-validation. Yeah, so as I said, I'm Wolle. I actually am a guy from Hamburg because I did my PhD there with Felix, and I studied before that in Hamburg with the other guys here. And then Backend was founded, so the company behind SpeedKit, which is a company centered around accelerating websites. And I did my PhD in that context, and that was pretty cool because, yeah, thank you, because I could combine my research and my teaching with what backend practically does. And this is quite cool because we actually had the opportunity to do research that solves problem people are actually interested in. And as you can see, my research was centered around stream processing and database stuff, and backend is accelerating websites. And this is kind of the innovation that drives SpeedKit as a technology. I built the data engineering team there, and last year I pivoted to the university. So I left backend, so my developer job behind, and then went to the University of Oldenburg. And this is quite nice because now I'm only looking at the data problems from a scientific and research perspective, and we're somehow trying to get actually practical problems and solutions into the research community. And this is working quite nicely. And today I'm talking about the pipeline for data processing that we have built over the last years and try to get across what the problems are that you have when you are trying to get huge amounts of data and do interesting stuff with that, because you get lots of crap when you're working in the internet, and this can be a problem when you're actually trying to produce insights. So there are three main takeaways in this talk today. The first one is that data validation is important. And to get that across, we will basically look at the data processing pipeline at backend and see where data validation comes into play and why it's important. Then we'll talk about data quality. So what is data quality? What makes it good? And in that context, we also talk about constraints as basically some kind of rules that you can define that tell you what makes your data good and what aspects of data quality are important. So that are the different dimensions of data quality. And finally, we'll look at what makes that difficult at scale, because first we talk about what the idea is, and then we talk about how we actually do this with millions and millions of data points. And this is quite a challenge in itself. Yeah, so as I said, we developed a data pipeline at backend over the last years, and this is the rough overview. Just that you know, there will be a talk next week by Felix. He's the guy here in the front seat. So if you are at Code Talks next week, check that one out. You'll get more details on what exactly happens in this pipeline. I'll give you a very brief rundown right now. You know, on the left, you see that data collection is happening in different browsers. For example, Internet Explorer, Chrome, Firefox, yeah, maybe Edge, whatever, you know, the browser thingies. And people visit websites, and then the code in the browser takes data points like performance timers and the URL and information on the user, like the browser and so on, and sends it to some kind of ingestion backend, so like different storage systems. Then we have these data points basically sitting, let's say, in raw storage, and we do things with it to make it actually analyzable, if you will. And finally, we have people doing the analysis, like generating insights. This is the running example for data validation in this talk. And there are four main steps in this thing here. So the first one is, as I said, collection, ingestion, and then processing and analysis. And processing and storage, the part in the middle, is quite diverse at backend because there are different use cases that we have for the data. So for example, we have dashboards that give you a summary, like overview, and you need special systems to store data that you can like access summaries over 3 months worth of data quickly. But then you also have use cases where you want to debug individual sessions and individual page loads. Maybe there was a problem with one specific debugging session that a developer tried. So you have to also have this high resolution individual page load granularity data. And maybe you also want to have machine learning models that predict things. Like, for example, we're working with the idea of predicting clicks. So we are trying to analyze what user sessions and user journeys are and how you can actually foresee where people are going. And this is very diverse. So you need different ways to process data specific for those use cases. And obviously, you want to make sure that the data that you are using for these specific use cases is actually good data. So the goal of data validation in principle, and this is not specific to backend, is that you verify and make sure that the data in the pipeline is actually acceptable for what you are trying to achieve. And on a very high level, like very abstract view, this can be anything. So for example, it could be for external reporting, meaning in the case of backend, we're accelerating websites, and then you want to tell the customer how fast they have become. So you need clear numbers so that you're actually not lying to them. And if they look at Google Analytics, it kind of matches up. Internal reporting is another thing because you also want to debug problems yourself. You want to optimize the product. So you need a clear view on what is actually happening. And ultimately, decision making, like business decisions, strategy, planning, and so on, also requires you to know what the current state of affairs is. So data validation is important, and it can be integrated at all places in this pipeline. So for example, you have to normalize input when you take measurements. Then maybe you have to do some kind of pre-processing before you actually store data so that it's more efficient or unified, like a unified format and so on. Then you may want to apply different business rules. This could happen, for example, in the processing stage where you're writing the data for the different use cases. And you also get complaints and bug reports. And this is also a kind of validation because people tell you when things are not good. Yeah, so there are many aspects of data quality. So different kinds of like aspects, what make data good. In this talk, we'll concentrate on 4. You see them here, and we'll talk about them one by one. And the first one, I think this is kind of the most intuitive one, is completeness. So the question here is basically, do we have all the data that we need to assess page load performance? So this is obviously for the running example, but in a different application domain, you would have similar questions. And in the case of page loads, you can imagine data something like this. Somebody clicks on a website, and then the browser doesn't send one big data entry to the ingestion system, but rather individual data points. For example, when the page load starts, you have a bit of information. Then you have, like, the page is fully loaded, you have a bit of information. So you have different beacons that arrive over time. And then we have to collect all these different data beacons here and merge them together so that we have one record. And this is basically the page impression or the page load that we are talking about. And obviously, you have many of them, but the idea is that you have individual portions of the data, and sometimes you don't have everything that you need. So here's an example of what the data could look like. This is kind of close to what it looks like at backend, but with fewer attributes, obviously. And you see that we have information like a timestamp for a page load and an identifier, the browser, some performance timer, here's the LCP, also a session ID that tells you which page loads belong to one user sitting. And then you also have the URL that was visited. And when we're talking about completeness here, the first thing that you may notice is that there are some values actually left out here. And this is a problem because obviously these records are not complete. And actually, last month, Eric here published a blog post on a specific problem that is related to completeness because he looked into a specific kind of data beacon that you send from the browser to the backend, and that sometimes get lost. So that's the unload beacon. And unload beacon reliability is a very good example of why completeness is an easy to understand but very complex to master challenge, because it's very difficult to make sure that your data is actually complete. So this means that sometimes you have data beacons that just don't arrive at the back end, and then you have to understand, like, is this happening very, very seldomly? Is this really a problem that we need to address? And he checked it out and found, yes, we should look into this. So then the question was, okay, sometimes we have this last beacon in the session, and it's kind of getting lost. When exactly is that happening? Like, for which beacons exactly? And does that depend on the implementation of this sending approach? And then also, for what user is the problem? Like, for which browsers? Does it differ by browser or by device type? And so on. And this is not easy to answer because there are different ways that you could use to send a beacon, and you have to choose the best one. So there are different like event hooks basically that you could use. This is kind of available everywhere, and then there are also experimental features in Chrome, for example, that you can try, but they are not available everywhere, but only in Chrome and only experimental, perhaps. So it's kind of difficult to decide what you should use. And yeah, also next week at Code Talks, there is a talk by Sophie from Backend, and she also addresses this example, but from a different angle. Like, I'm talking briefly about the results that Eric and Co found. She's talking about how you can communicate the findings that they had effectively. So there, basically, the perspective is more from the how do you communicate this kind of result. I'm just saying it's very difficult to find these results and do something reasonable with it, because what Eric found was that there are different like reliability statistics, if you will, depending on the beacon strategy that you use for this last beacon, and they also differ by device type. So you see that there are different event hooks, and they kind of yeah, they're kind of okayish, but basically you lose 10% all the time, with the exception of the topmost one there. But that's the experimental implementation, so you can't use that for all platforms or at all right now. So basically, you're stuck with a solution, and you know that 10% of all your beacons get lost anyway, and the before unload handler there at the bottom is particularly bad, and it's also particularly bad for mobile devices. So what you know when you analyze this kind of thing is you're losing data sometimes, and you also have kind of a data skew, because if you analyze information that comes with that beacon, the desktop data is overrepresented. And this can be a big problem. So Eric also checked out different browsers. So he tried more browsers, but those are just 3 of them. And what you can see here is that visibility change and page height hooks are basically working best and kind of consistently good. With the other event types here, there are problems, especially in Safari for the before unload. Now, if you checked out the last slide, then we saw that browser performance was bad for this particular thing, and it's particularly bad for Safari. So we again checked, okay, could we maybe use a combination to get the best reliability here? You know, so basically take both hooks and just send the beacon with the first hook that fires. And he found that the combination of the both rather stable hooks there works pretty well. And on the right, you can see that it's also the combination that you can safely use, because if you use the other hooks, then you change the behavior of your website, because you can't just use any hook to send those events. He told me that if you use, for example, the for unload hook or the unload hook, then you actually cannot use the backward forward cache anymore. So this basically changes the way that you could navigate on the page, which is totally dangerous because you don't want to change the behavior of the site that you're tracking. And this is just to make the cut to the actual problem. all related to completeness and just about how can I improve completeness for this particular data beacon. And there are loads of different points in time where you send data during the page load. So this is a very complex task if you're optimizing this all the way through. Yeah, so back to the dimensions of data quality. The next one that I want to talk about is consistency. So we have the check mark for, do we get all the data that we need? And now we're talking about, okay, we have data, but does it actually have a valid format? And does it comply with our business semantics? And if we look at our data here, something you may notice is that there is an Edge browser here. And you say, okay, why is this a problem? Well, the problem is that we have 3 page loads there with the same session ID, and the first 2 are Firefox, and then we have Edge. This doesn't make sense because typically you don't change the browser mid-session. How should that work? But it's the internet. You can get stuff like this, and then you have to decide what to do. One idea would be, okay, I want to have the same browser everywhere, so let's do some kind of majority vote. You could do this. You could also say, okay, maybe the latest reported value makes more sense. Then you could say, okay, I just assume everything was Edge. And you could also say, for example, I don't know, I set it to null because I don't know there was a problem. But the thing is, you have to decide what you want to do. This needs to be resolved. And also, in this example here, we have different formats for the timer values. So sometimes we get a string, then we get some kind of double or an integer, and you have to decide what the data format should be, and then you have to convert all this. So for example, you could say, okay, let's convert this to integer. It represents milliseconds. Okay, and now everything is consistent, but it's not really accurate. Like, not all these values make sense. So for example, the timer value here says, okay, we have a page load, and there are like 690,000 milliseconds LCP, which is like, I don't know, like 11.5 minutes or so. And this is not realistic. Like, this is not a value that happens in the real world. So this value does not really represent an actual page load. It doesn't feel like it's broken. So you have to do something with that, and you could, for example, say, okay, I'll just remove that so that the value that we can analyze is at least healthy. Yeah, and then the final dimension that I want to talk about is uniqueness, which means do we have duplicates here or not? And what you see here is that the bottommost page loads have the same ID, and the bottom one doesn't actually have any values apart from the URL. So it's kind of questionable what this thing tells us. And just to illustrate why this could happen, let's look at an example here. So if you zoom out and think about user activity throughout an entire day, something like this could happen. Like, someone clicks on a website and then, okay, I have to leave for work, then closes the notebook, opens it again during lunch break, clicks around, visits the website for red shoes, then goes to the page for blue shoes. Nice shoes, by the way. Let's buy them. Then goes to the checkout, buys the shoes, and then closes the notebook, keeps working, and then comes home in the evening, opens the notebook, and then you get, for whatever reason, some kind of page reload or some beacon is being sent that was not sent during the lunch break because you shut down the notebook so quickly. And then you have a duplicate. You have to somehow understand that you have 2 checkout beacons, but the one that you got during lunch break is the actual one, and the other one is just a duplicate. It doesn't really contain info. It's just a phantom, if you will. So you have to understand this and then also do something with that information. So for example, you could say, okay, let's just drop the one where we know it's a duplicate, or maybe if it contains information that was missing in the first one, let's use that information to enrich the first beacon, like the first page load. But you can't really keep both of them because this would skew analyses depending on what exactly you're looking at. Yeah, now this is the rough idea. So like you have an idea of what makes data quality good if you go by these dimensions, but you also need to specify this in a way that you can have code that makes sure you have good data. And you can use constraints for this. So it's kind of rules or conditions or limits that you define that your data must adhere to. So for example, type checks, you can say like range checks for performance timers. But you know it can't be a negative number, it doesn't make sense. Or you could have something like a format that specifies how specific strings should look, or if you have a complex tracking attribute like a JSON blob or so, you could specify a schema. This is basically the simple case, and you can also have complex conditions like the one where we had the browsers that differed across the session. You know, this is kind of a cross-record or cross-field uh, condition where you say, hey, if you have the same session ID, then you also have to have the same browser. When you work in databases, something like a referential integrity constraint is also a typical constraint, so that you don't have pointers pointing to things that are not there. And you can basically define anything in your business logic depending on your domain. But the important thing is you have to specify rules. And there are different frameworks that allow you to enforce those rules. So here's like a very small Python snippet where we use Pandera to define a data schema for our example. So what you see here is just how something like this can look. Here we specify, okay, the timestamp column is a datetime object, and then we have page load ID. This is a 8-character string, and the browser has to be either of Chrome, Edge, or Firefox, and the LCP needs to be between 0 and 60,000. And the session ID needs to be like an integer. And if you have a schema defined like this, so basically rules how your data must look, then you can validate data items that you, for example, load from your database that you get from your tracking devices. Just for an example to show you like how this works in principle, this could be a good data record and this could be a bad one. And it's bad because the timer value is too large. Like this was the broken thing that we saw on the slides earlier. Then you could also execute code like this to say, okay, go through all the records and then try to validate them. And if it's good, print that it's good. And if you get an exception on validation, print that it failed and what the problem is. And executing this would look like this roughly in your Python notebook. So the first record would be nice, and the second one would blow up in your face. And then it says, okay, the attribute with name LCP is broken. And at the bottom there, the failure case is 692654, so the very large LCP value. Okay, so this is the idea. So this is how, in principle, you can collect data and then make sure that it's good quality. But obviously, you're not doing this in Python on your notebook when you have tracking data from like, I don't know, 900 million clicks a month or so. And just to illustrate this problem, how it looks at backend, we have a dashboard for data errors, so things that are broken in the tracking data. And this is April this year. So we had almost 500 million data errors in that month. So this is quite massive. And then you see that if you split them by type, you have a few attribute errors. So this is something like the, hey, the LCP value is too large, but 2/3 of these problems are aggregation errors. And this is just our speak for a complex problem. Like, for example, you are waiting for dimension values like the browser and the device and the origin or something like that before you can go on with processing the data. And if that is lacking, then this is an aggregation problem. So these are like 300 million complex errors. And if you check out the individual causes for this data error actually pop up in the statistics, you see that the majority is missing values, which is okay. But we also have like blank values. So someone sends us like white space strings instead of nothing. Eric, thank you. The blank thing is really annoying sometimes, and out of bound ranges, for example, like this LCP thing, also an issue. And at the top, you see that we have loads and loads of very small, like small portions of problems, and you can't really address all of them. You can't even see what it says there because there are so many tiny issues that are really hard to debug. And the problem here is that if you have so many errors, you really have so many errors, so much data, so many customers, like so large scale, it's really difficult to attack the data quality for different reasons. Like the first one is not the sheer amount of errors, but it's that the example doesn't really reflect how complex things are in practice. So we have 6 attributes here in this example, but I think right now our tracking data table has 160, 150 attributes. So it's really time consuming and complex to specify constraints for this thing. And also things are evolving, so you have to evolve the constraints as well. Um, Further, I think that we have, for example, dashboarding storage that gives you summary aggregates so that you can display something like a count of something or like summary metrics over a huge time span quickly. And this means you have a derived storage. You have the raw data, and then you have a second storage that contains like a summary. And this means you have to have a new schema, and you also have to have constraints for the schema, and you have to monitor this thing as well. And this means you have 2 storages now. But obviously, you don't only have 2. You also have different data sources for enriching your data set. So for example, we have some kind of huge database where we munch everything that we can get to collect information on websites that we try to improve. So we also monitor like Crux information, like the page speed monitored by Google, or something like our HTTP archive, or maybe similar with HubSpot built with all kinds of things could be plugged into this. And then you also have specific output for the developers that need the debugging capabilities, for people looking at summaries, for sales, for marketing. They all need specialized views on the data, and you always have to basically cater for their needs and sometimes create new constraints that need to be maintained. And this means you have to automate this kind of thing, and this is super complex. Or you have to have many people managing this manually, which is also a hassle. Then if you have huge amounts of data, doing things in batch, like for example, computing daily metrics on daily data is difficult because either you have to wait until the day is over, or you have to recompute things all the time. And that means in the morning it's quick, at noon it's difficult, in the evening it takes forever. This isn't really feasible, so you have to have some kind of incremental computation scheme where you always compute delta summaries, and we have 5 minutes. We compute the summary of the last 5 minutes, and we do that every 5 minutes. But our dashboard needs to be capable to work on these deltas and not require like the absolute values. And this can be difficult. For example, if you want to have something like, let's say, the bounce rate for an entire day, you can't just compute some percentage. You have to compute counts and divide them by one another if you do that incrementally. This can be complex, and just as another hint, this is something that Felix also addresses in his presentation next week. Yeah, then even if you manage these problems, your data tends to be very volatile. So this is basically traffic by 2 different customers over time, and what you see here is that it varies over time. So during the day, you have more traffic compared to night times, and you also have spikes from time to time. So sometimes just stuff happens, and you have more traffic because there's an offer or whatever. And you also may notice that we have EU and US customers here. So that means there is kind of a variation over time, but they are shifted compared to one another. So you have periodicity here, but it may be a different one for each customer. And also, this means sometimes you can have one big deployment because you have so many customers that you have the same basic load on average, but typically you don't. So you either have to have ample resources all the time, or you have to have a system that scales up and down dynamically to make it cost efficient. This is also difficult because, remember, we're doing everything continuously. So you can't really scale up or down without downtime. And this is super difficult to realize in a way that you don't have relevant downtime. Yeah, and then I think the combination of continuity and volatility, I don't know a word for this, but I think there should be one, so I call it continuity. It's just you have continuous data and it varies all the time, and you need to stay online, and this is just crazy annoying. So what you see here is the data errors per hour for the first like half year or so. And what you see is sometimes people deploy something and then stuff happens. And what you see there's the red customer, super nice and chill, the blue customer, typically nice and chill, and the yellow customer there, I don't know whether you can see it, that's why I added the arrows there, just yanks up the data errors per hour to 500,000 suddenly. You know, this happens. And if this happens, typically there are different red alerts that show up, and angry people write you on Slack because things don't work, because you validate everything. And now, for example, a big customer deploys something and every single page load is broken, and your validation logic just goes amok. And this can really make your processing pipeline grind to a halt. And this is a problem because you have one big pipeline for 500 customers or so. And if there is one very, very nasty customer, everything stops for all of them. This is bad. So you have to say, okay, we need to stay available. What's the problem? So you need to attribute this. You need to find out what the hell is happening, who is causing this. And if you know who is causing this, the question is who can fix it? Because if a customer deployed something, you don't know whether you can deploy the fix because you didn't deploy the problem. So, you know, it's kind of difficult, and this is a very real problem if you are doing this at scale. And this is basically the summary of the problems here. So I don't have the solutions because I don't have time for this anymore, and we're also not finished building this. But just as a few pointers, how you could go on if you are in a similar spot. What you need to think about is, for example, having logic that infers constraints so that you update the schema and your constraints update with it. You know, you can adapt to schema changes. Then you need to think about how to compute the computations that you do incrementally over time so that you don't have to recompute things in batch-based fashion all the time. There are different tools and frameworks that you can look into. Some just for using them in Python notebooks, some for cloud purposes. Google have their own, Amazon have their own, everybody has their own. Some are built on Flink, on Apache Spark, whatever. There are different options. Maybe you want to check them out. And then in general, you have to think about issues like how do you distribute your data and how do you distribute the workload for validation? Because this is also, as I said, a problem if you have sudden spike of 500,000 errors per hour. How can you avoid skew? For example, if you partition by customer and your customers are like 10 times the size of other customers sometimes, this is not a good idea. But it's sometimes difficult to skew otherwise, to partition otherwise. Then you need to think about efficiency. Perhaps you can sometimes just drop data or like compute summaries or approximations of things instead of computing the actual thing. And then also you have to think about operational challenges. For example, do you have a problem? Like, is there an anomaly? How can you fix it? And how can you shed load if it really is required? For example, can you deactivate validation for this one customer that is breaking things for everybody? Yeah, and the summary of the talk is basically data quality is important. You can measure it along different dimensions. You look at completeness, consistency, accuracy, and uniqueness here. There are others depending on your use case. For example, timeliness is often cited. But you get the picture. Then constraints are used to specify your expectations about the data, and you can define them with code so that you can actually have software validating your data and making sure that there is good data quality. And this process is called data validation. And it's important for anything you do in your business. If your business has anything to do with data, which is probably all business. And at scale is very difficult. So in the example of web performance tracking, I outlined the problems, for example, very complex schemas, very many data sources. You have volatile data, you have continuous data. Everything is moving all the time, and stuff breaks. Yeah. And this is basically it. So thanks for listening. If you have questions, I would be ready now. And The resources are at wallet.science. Thank you. Yes.
Do you think that large language models are an interesting angle for data quality? Because one thing that I found is that ChatGPT code interpreter is quite amazing at doing kind of on-the-fly constraints, looking at data, finding null values, or well-formatted dates, and kind of fixing it on its own. Do you think that's the route for the future?
Okay, so the question I'll just repeat it is whether I think or not that large language models are kind of an important tool or the way to the future in terms of data validation, because the code interpreter is pretty impressive. Yes, I think obviously for every problem today, we have to consider large language models because it's just crazy what they sometimes can do. And I think that if you have a language model that is trained specifically, you can also spot errors that are hard to define constraints for, because they are pretty smart sometimes. I think one problem that you have right now is that they are not efficient in a way that you can just come through a billion records through such a model. And also you have context length. So if you're trying to like do this ChatGPT conversation style, you run into the limitation that the thing can't even remember the data for a single page load. So fun fact, we had like tracking these data errors can get quite extensive, and just tracking the information for the different errors can give you hundreds of kilobytes per page load sometimes, and I think one example is like resource tracking, resource timings. If you're trying to understand everything that happens, you would have something like 20 megabytes per page load, and you obviously can't track this, and you couldn't give this to a language model. So I think uh, there are several ways how to use this, but I don't think ChatGPT is the way. You have to have specific models. But by the way, as you mentioned, constraint definition, I think this might make sense, because you could also say something like, "Hey, ChatGPT, please generate a table definition out of the student university context," and it would give you reasonable table definitions. And I think this could be a way to automate like simple constraints, for example. This can work now already. Like you have the schema here, please define constraints, and it would understand what is a performance timer, what is, I don't know, like a dimension, what are reasonable assumptions on the values, and you have a good starting point. I think this could work now already. Yeah, thanks for the question. Are there more questions? What about the 72 people online?
It's 12 people right now, but
Whoa.
no questions, at least not for you so far. The only question that I got from the chat is, what is the best country and the best city in the world? Obviously.
Yeah, so I'm inclined to answer Oldenburg for monetary reasons.
Oh yeah, we actually have one question. What is the most annoying thing about collecting data?
Okay, I'm gonna answer Stefan's question. Yeah, right. The question is, what is the most annoying thing about collecting data? Is that right?
Yes.
It's really hard to choose one thing, but I think one of the more challenging aspects is, at least at backend, it's a very complex beast that we are building, and nobody really understands everything in there. So you have to communicate with people a lot, and it turns out that people assume things, and other people assume other things, and this communication thing is kind of interesting. You have all kinds of syncs, and then for example, we have like 150 attributes, and there are cases where you define an attribute and somebody writes collection logic, and it should, like, for example, Eric builds something, the data is being written, we have a database table definition, the data can be queried, and like 1 year after we released this, he does an analysis and says, hey, the data isn't there. And then you start looking and you have to find out what happened. Nobody remembers anything. And then it's just, no, it's not that one person builds this. And the moment you realize something goes wrong, if you are not automating your validation, it's typically too late because you're only looking when you're interested, and then it's too late. So I think this can be very annoying, and this is why data validation is so important. Yeah.
Or communicating with people.
Yes. Communicating with people is the answer. A. I mean, it's very believable that this is my most annoying thing. You heard my answer. All right, so thanks for the attention. I'm heading to the bar now, right?
We have a second talk, so we will do a quick transition for everyone here and also for everyone online. And then,
Great.
I don't see Martin. He's there. Yeah, perfect. Anybody wants a drink?
Nimmst du mal weg?
Anyone wants another drink? That's fine.
bitte.
Das ist eine Frage gestellt. Das ist ja noch
Justin, kannst du mir ein Wasser nehmen? Danke.
Was sind was wollen das? Constraints für LCP.
Ja, das ist so blöd. Die wir beim Hackathon hatten, die waren besser, die Runden.
Und die müssen wir so scharf, dass es das zerstört. Zu wenig gegessen.
So. Okay. Kannst du anlassen, glaube ich, ganz gut. Sieht man ein bisschen was, ne? So. Everybody's back? Yeah, it's fine. If it's on or off, I'm fine. I can see the faces. That's important to me. Cool. Yeah, guys, I would like to start. So thank you for having me today. I would like to talk about Lotto 24 and our Angular SPA, what we have built, and the challenges with page performance that Angular imposed to us and that we learned from, and hopefully share some best practices with you in case you are also working with Angular. But there are also some hints that are relevant for other single page applications as well. So let's start. I start with a short intro on which kind of websites we operate, talking a bit about what is our business interest about performance, what we are looking at it. I will give you a small overview about the evaluation of the ZIA frontend platform. Then we go straight to the Angular SPA pitfalls for performance that we fall into. I give some small little demo. It's a small little application where I coded some issues, and I will solve some of them here with you guys, but I leave some over for you on GitHub to check out and investigate as well if you're interested. And then I talk a bit about how modularization helped us tackling a few of the issues and how it will help us going forward with performance. So let's dive in. What do we operate? Basically, ZIA is the operator for the websites Lotto24, Tip24, Lotto Web.de, and Lotto GMX.de. And we have an Angular-based code base since AngularJS 2015. And yeah, before we had classical Java-based server-side rendering, and then we made the step due to some new requirements with user experience and interactivity to SPA. We also went a journey to migrate from AngularJS to Angular 5, 6 straight in 2017. And whoever of you guys worked with Angular, you guys know that was quite a huge change because Google basically changed the whole approach about Angular and its internals. So that has quite a lot of impact. Our shop, as you see, it's one code base, but it's 4 different look and feels. So our shop is component library based since 2020. And yeah, we are running like 20 deployments per day, sometimes more, sometimes less. I think the peak was even 50 when we are migrating Lotto platform into the Z platform. So just a few words about me. Yeah, I'm Martin. I joined ZIA 2016, actually as an iOS developer, but then 2017 I was working in accelerating microservice development by introducing an API gateway, actually out of necessity because we didn't have a public API. We had something for the shop solely, and when we joined with apps, we needed something standardized with standard formats to work on it. Yeah, and after that success, I joined Team Website. We migrated everything to be API based, and yeah, the few more details can be looked up. You can find me on LinkedIn, Twitter, and GitHub. So on Twitter, I will, or on X, sorry for that old logo. I will share also the repository and the links to the presentation. But you will also find it on the Meetup channel later. So yeah, page performance, the context. So why are we interested in page performance? Since we have a single page application, we were quite happy with soft navigation. So like once you loaded the page, you navigated to another one. That was something we were quite happy with. But the initial load time, it got slower over time. And the more features we added, it started to get slower and slower and slower. So you could say like every feature slowed down the page. And in the beginning, we didn't really knew what was the issue, right? So that's why we looked deeper into it, and yeah, we analyzed what the reasons were, and I go into that in a minute. So which kind of data do we look at? Yeah, Wolle made a fantastic presentation about the same challenges we went through on a smaller scale for sure, not on 500 million requests, but we kind of have 100 million for the years and try to figure out. And we kind of fall also in these fallacies of looking more at desktop, having kind of the real user monitoring data, not having the right things. So at some point, we fall back to look at what Google provides, and Google has some dashboards. And we figured out what our Lighthouse metrics showed us was not the same. And in an essence, the reason for this was we were testing Lighthouse not with the setup that our customers use, right? We were using way older benchmark browsers. We were using older configuration. So what we figured out was that our customers had newer devices, and actually we were a bit better than we thought, but still not where we should be. So how was the evolution? I said we had this hybrid self-made rendering. We had a Java backend, and then we had some kind of Angular application inside of a Spring Boot application. And basically, we made the turn to fully client-side rendered and API-based application in 2020. And we had a much better developer experience. We were way faster delivering features. But the reason why we looked deeper in page performance was we saw first customers complaining about loading times and also partners. So let's dive a bit on how it works in comparison, right? So an old SSI application, you have a Spring Boot application, it collects the data on the backend side, and then it renders some kind of the data of your application into your SPA, into your index HTML. And then your single application, page application downloads and actually takes over, right? The problem with this is you kind of implement features twice, right? You kind of implement routing on the server side because your server needs to know every kind of route and needs to know every kind of feature. And in the front end, the same thing happens, right? So I have twice the development. When we look at the SSR with client side, you are straight downloading the features, you are straight downloading your index HTML, and you load the single page application JavaScript. The biggest culprit here, though, is what if your JavaScript is simply too big? What if your JavaScript is 2 megabytes? Imagine you have a fast internet connection and you have even 4G with a very good connectivity. You load 2-3 seconds minimum with that size. And since we're on mobile, people don't have everywhere 5G or 4G. People doesn't have the fastest connection everywhere. Sometimes people wait 6, 7, 8, or even longer seconds. So that's actually what we saw in data. So there are some solutions to that nowadays with Angular, but just recently, right? So there is a new hydration feature in Angular that helps with server-side rendering and combining client-side rendering. But then in the time when we worked on this was not available, and it didn't help with the core web vitals. So what were the pitfalls? One pitfall is waiting for network before you show something to the user, right? The web vitals, they measure the largest content for page, measures how long it takes for content to be displayed. And of course, if you wait for the network, it delays when the customer sees something. So you gotta display something in between. Then keeping the SPA bundle static or pre-renderable. So one of the successes of SPA is only possible if you can cache the assets. So you cache it on Cloudflare or another caching provider. And if you kind of inject server side like we did in the early days, data that's dynamic and that's specific to a customer, you cannot cache. If you inject and server side render into scripts, then you cannot cache those scripts if they are different for each and every customer. And I think that's the most problem most of Angular applications have. Keep your main bundle to the absolute minimum. So the goal here is really Angular by default has 69 kilobytes, we were at 1.4 megabytes on the peak. And actually, the reason why it is, we come to it, but the goal here should be your main bundle. Your application should not ship any feature. It should only ship the framework and leave it then to code splitting and lazy loading to load features. And another thing is, in an SPA, especially in Angular, you don't have much control about when the API calls happen or when the JS is processed. This is something the framework does in the background. You're working with Angular modules, and it's not obvious for Angular developers or for front-end developers that this has impact on the bundling or it has impact to the way how the code is initialized. At least not apparently. So let's take a look at the demo. So I provided a small example, which you can see here. I hope the delay works. So basically, it's just a page with some quote, and the loading is implemented this way. We are loading, you don't see any content, and then the network took 2 seconds to load some data, and then it appears. And you see I implemented some debug code, and we see we have 2 largest contentful paint events from the browser API. The first one, when this content was visible, here the largest contentful paint was the footer. And then the second one, when the big, large teaser arrived. And what Google takes into account to judge your website is the last contentful paint before interaction, right? So before you interact and abort, Google takes the last one. And this is here 2 seconds. Why is this? Let's look a bit into the code. So we have an Angular component. That's kind of the HTML for it. And we have here some network call that I just delayed to simulate some network delay for 2 seconds. And basically, we have an ngIf that says either we have the data, then display the whole thing, or we don't have the data and then don't display anything. And that's common practice in many Angular applications. And the first thing you see when you Google how to fix it is you can provide some kind of fallback. So in case you don't have the data, you can go and you can kind of provide an else branch and then provide another template that is displayed as a placeholder for the time when your network loads. So talking though about development at scale, imagine doing that for 100 components. I have yesterday just counted the amount of components we have. I think it was like, Olaf, correct me if I'm wrong, 200 something components. Imagine for each of the 200 components, you need to duplicate the DOM and kind of match the original look and feel. It just duplicates the work you have to do as a developer, right? And that's obviously not something we can do at scale and not something that our 7 teams would accept as a good solution from a platform team. So anyone an idea how to easily fix that and avoid this kind of code application problem? Any one of the audience? Fetch priority, yeah. Kinda, but still, how do you pre-render the skeleton kind of thing? You still have to develop that skeleton, right? So the issue that you duplicate code is still apparent, right? No, the easy trick is provide some defaults. Provide a default. So when you don't have the data from the network, just provide some default. And I did that here with my example. I just went to the code and provided some default values. Then I can render earlier, and the largest contentful paint time shifts to the moment when the first rendering happen, and then update your data later. We did it in the basket, for example. Sometimes you don't want to confuse customers with invalid data, right? You don't want to change prices. Put a placeholder, put a -0 or put a loading sign or a loading GIF. There are many ways how you can do it, but that shifts literally it shifts the KPI, and it's also good for the user because he sees a bit earlier how the page will look like and can already navigate on certain things. So yeah, run a lighthouse test. The first lighthouse test on the page without the default was like a 65 score. The second test was 95, so largest colorful paint. It's great again. And it does not only help with largest colorful paint, it also helps, of course, with cumulated layout shift, because if you already reserve the space, then other contents won't shift. So yeah, that's here the code. Default if empty, just some placeholder image with an 8, switch map for switching to the real network tab. That's it, and you save the whole amount of the placeholder. So let's take a look on a more complicated thing. So this is how Angular composes features and how the bundling makes you ending up with tons of code in your main bundle. So usually in Angular, you have an app module. That's what you start with for your single page application. And then that app module is importing a lot of modules that provide features, like the testimonial module that provides some services. And usually these services, they contain shared state in your application. So you maybe have a session service, you maybe have a personalization service, and those contain data you want to share in your application among many components. Beside these services, you also have the components that are imported in the modules, and they provide what we saw. They provide the template, they provide the CSS, and they also provide the TypeScript code that can compile it. When we look in a more complicated example, it gets very apparent that this kind of code is exploding very fast. So here I just take another example where we have below some more testimonials. It's another component that's for testimonial battery to kind of show them horizontally. And when you think of on mobile, for desktop, it's all fine because on desktop you see everything on this. But on mobile, that's what the user sees. That's what the user would see in the mobile viewport. So all of the code from the content below the fold is actually not needed, but it still consumes the main bundle size, it still consumes the networking because it's still initialized, and it consumes the CPU power because all of the code actually runs. And we figured out, especially on Android devices from a few older devices, that is even a more severe problem, or can be even a more severe problem than the networking itself. So basically, that would be what we could save in that viewport. And yeah, basically, that would help us a lot already. And also think of scaling when you work with multiple developers on it. Imagine now some developer says, okay, I need some data from the user service. So I need a dependency from the testimonial service to the user service to personalize my testimonial content. Then again, you need all of these kind of bundles. You need all the modules. So when you think of, we are working with 7 teams on this huge shop, and when you think of having all these kind of components and modules, then you kind of easily run into that situation. So yeah, just repeat why code splitting matters, CPU time, network time, JS time, that's important. And even if you use SSR, I get asked the question, wouldn't that be irrelevant if you just use server-side rendering? You still have another KPI coming up, interactive next paint will be March, I think, next year. And you still have the necessity to load the JavaScript bundle to have interaction, right? So if you have the server-side rendering and you don't have the JavaScript bundle, you can click, but nothing will actually happen. So even in that scenario, we absolutely need to take control about our size. So how can you do that? And not only Angular, but basically in any TypeScript application is using dynamic imports. So you kind of, instead importing your feature, you kind of use ng container and you give it an ID, and then you can have access to the variables as view container references. And the dynamic import tells your bundler, might it be Webpack or any other bundler, that this code belonging to that component should be split out, should be not in your main bundle. And then once you loaded it with the dynamic import, you can create it inside your view. So there are some loading strategies you can do. You can like load everything from top to bottom. So you do every kind of component in a container, and you load everything on your page from top to bottom. You could use Angular router for this. If you're familiar with Angular router, it kind of gives you, URLs, and then URLs determine what is loaded. The Angular router is pretty complicated. It's not made for this case. It's made for routing. So you have kind of an overhead to the history API. And loading from top to bottom might be correct, but sometimes your largest content for page is not on the top, and you might have multiple components even above the fold. So you sometimes need to still change the orders, right? So what we did is we are using the DOM. So we are using Angular, and we built a small library around that topic that helps you to define those modules in a central place. And yeah, let me give you a small sneak peek to that. So import orchestration. So how does the library look like? So basically, you can go to your app component. And what you see here is we have kind of an annotation for this. So where you can say add imports, and here you define all the dynamic imports you want to do. So all the code that you want to split. And you can import standalone components. That's a new feature of Angular 16. You can define also, you can also load ng modules, so you can define various things, and you give it some kind of key, right? So you just specify, this is now my testimonial feature, that's my text feature, that's my battery feature. And you can then use it just the way I showed earlier. I have it here on the home component. You can just use it with the engine container as I showed to you. That's it. That's what we saw also when we made it self-made. But the big benefit of it is that we also, let me see where I have the configuration. So that you also can provide an import orchestration. So here you see the same case that you defined in the annotation, and you can now specify in which order the features should be displayed and downloaded. So now I said first the testimonial hero teaser, then the text, then the battery. I just can go here, put 0, 1, and then 2, reverse the order, and basically you will see new compile. So basically you will see it should download in the reverse order. So let's see the timeout. A bit. Maybe too slow. Okay, so it should load in the reverse order. I hope I get it running maybe for a bit later. So okay, so what it helps us to do is, like, we have over 450 modules, different features, different states that we load, and we can first of all define the render order, and not only that the render order differs, but also when you look in the network tab, you see that those features are loading kind of icons, they are doing network calls, and so on. So this gives us also control about what data and what kind of icons we want to load first. And yeah, we have central place for defining the orders. So yeah, that helped us a lot. For managing the complex state, we now have control about what is displayed, and everything that is off screen is not in the main bundle. And we managed to get the main bundle down from 1.4 megabytes to 300 kilobytes. And yeah, we hope to even get a bit lower than that. So Modularization boundaries. You saw earlier the image. Your app consists of many features. Then inside your features, you have kind of some states. And we talked about earlier that even though you do code splitting, if someone imports something from another module, you might still end up not having the code anymore in the main bundle, but bloating your feature too much, right? Imagine the states crosscut here. So we have two teams, team A, team B, both own a feature. Imagine now team A does a dependency to team B's state, and team B makes another dependency that bloats that state. Then team A suddenly has an imperformant feature. So it suddenly gets slow. Team A doesn't know what happened. And team B didn't even know that they caused some harm to another team. So what we do to solve that kind of issue is we are utilizing NX. NX is a monolith, and it gives us the possibility to define boundaries. So we kind of can define okay, certain types of libraries are allowed to import certain other ones. So features are obviously allowed to import state. But state, for example, is for sure not allowed to do a feature. So here, brief overview. We have app. This is basically our main bundle, our main app. It should only contain features in a lazy loaded way. It can contain shared state, it can contain some global utils, but it cannot contain some shared UI, some domain UI, all the library types that can make it huge. Then we have features. Features is like the place where we lazy load. It can barely contain everything from the same team. So the same team can provide UI. From other teams, it has to be specific marked shared UI or specific marked shared state. And we have some constraints on this. So a shared state, for example, cannot have more than a subject containing the state. It is not allowed to have any initialization logic in it. Initialization logic also must be lazy loaded by another module. So let's take a look here. That would not be possible because basically this import from team B, assuming that the C state is a shared state for another team, they would not be able to depend on a big state. They would need to create a new feature, and that feature can initialize the state. And then this new feature can be lazy loaded with our orchestration I showed a bit earlier. The cool thing about this is we also have compile time warnings. So here I just go into a shared state from our payment team. I now try to import maybe a feature. So import from, let's take anything from our acquisition team, achievement challenge feature, something here, whatever we have. And then you see even the IDE can tell us that a project tag with the name type shared state can only depend on libs tag with type shared util or global util. And that is really huge and changed our development process a lot. Earlier, we tried to keep the bundle sizes small only with bundle size rules. So we made rules like your main bundle cannot be more than 100 kilobytes. Your assets cannot be more than that. The problem with this is, imagine you write a huge code base, you do some code, and then it just tells you the code get bigger. Yeah, it doesn't tell you what caused the code to get bigger. And especially in a TypeScript environment, you don't see, obviously, what is the generated result. So that helped us to get semantic errors to our developers and really tell them, look, here you cross the boundary, and that can have potential harm to page performance. But not only this, right? It also harms testability of code. It also harms reusability. So we kind of address three topics in one: page performance, testability, code reusability, and that live during coding. So that was really a big game changer. Yeah, just to give an outlook on how we developed. So 2020, we kind of started looking more deeper. You see the green curve is our largest content flow change for Lotto. I think Tip24, Lotto24 just joined us end of 2020. It gives an overview about our platform, online platform, and you see the amount of users that have a good performance. So that means on mobile, good performance below 2.5 seconds is rapidly increasing, and we hope that the boundary rules, you saw there was kind of initiatives, and then kind of dropped again. We hope that the boundary rules help us to sustain the good trend and, you know, really put some kind of testing around performance. That's basically it. Questions? Thank you. Mhm.
How do you monitor performance? Like you mentioned that you actually track this kind of thing.
Mhm.
How?
So actually, we at Lotus24 we have a data team that provides like Athena and provides a real-time endpoint that we send our data through, and we kind of try to implement it on our own. And yeah, we did that, but we run into a lot of those problems, right? So we are now looking at Cloudflare. We utilize Cloudflare, and Cloudflare is offering some of these kind of analytics services for largest content paint and the others. But yeah, we gave up on maintaining our own tracking because it was simply too much work for us as engineers to have the beacons implemented properly and maintain them. And it was especially too much for our analytics team that should look at business features to also look at kind of performance and deal with the huge amount of data, right? But yeah, in general, we have some big data pipeline that gives us the possibility to track everything from the front end and to send millions of requests possible. Mhm. So the data, so what we do is basically we implement a performance observer, right? And we are having an API that's built in Go, I guess, where we forward the data. And then I think, I'm not sure how our data team does it, but I think this data is cached in between with Kafka, and then it's replayed and stored to Athena. So it's a bit more complicated, but I might ask one of my colleagues to give a presentation on our data platform. But I hear it from him a lot of the same problems that you were talking about. Thank you. More questions? Yeah. There you go. Mhm. Mhm. So what I mean is we are not using it for orchestrating, repeating the question. So the question was, Angular has a built-in service for routing. You are not using it, why? What I meant was we are not using it for orchestration of loading orders. We are using the router for routing the different URLs we have, like homepage and so on. But we are not using it for the order of the features on the thing. It would require us to kind of split all the code and the subroutes and provide configuration for the router. And the router of Angular then keeps track also in the history of it. Imagine now we just want an order of features to be downloaded, and then you use the browser back button, and then the browser back button would just make a feature disappear. That wouldn't make sense, right? So that wouldn't really fit to the use case we had. We wanted on a single page to orchestrate the order. We didn't. We use it still though for lazy loading routes. Mhm. Other questions? There you go.
If I understand it correctly, you're basically defining some priorities for the modules which you want to load. And did you have that integrated in your tracking pipeline so that you also can understand if these modules are at the end really correctly loaded?
In the right order, yeah. Actually, that's something we are currently working on. So we have this feature now since we have that done since a few months in production, and we are working also on our tracking. Yeah, but we don't have it yet live.
I am just wondering how you basically decide or how to basically improve the order, because if I imagine that I have now, let's say, 20 different components, I need to decide which component should be loaded first.
Okay. So what I said is we are using Cloudflare for what our users see. And what Cloudflare shows us is it shows us the top 10 slowest elements. So we get the div IDs, we get the classes, and we can see what kind of elements are slow. And that we use as a basis to optimize. So for example, Olaf, who's here in the crowd, recently had a look at our consent manager. We saw in Cloudflare consent manager was top #1 prio for slow largest content for paint. And he fixed it. So kudos, thanks to Olaf. And by the way, Olaf is also the creator of that library, and we want to open source it at some point. So yeah, great work, Olaf. Thanks a lot. Just to give some kudos. Yeah, that's a good point, and Cloudflare really helps us doing it. So that helps us to understand where to look at, and then it's about testing, right? Then we deploy it on our machines. Cloudflare also gives us information about which devices the customers used, which network speed, which kind of CPUs they had, and then we also tweak our testing to reproduce the largest content for paint. So we really go reproduce it and fix it. Thank you. More questions?
Does Cloudflare provide an API to extract this data, or do they have to use the Cloudflare dashboard to analyze it?
We are satisfied with the Cloudflare dashboard right now. That's why we haven't looked deeper, but I know Cloudflare has an API. I just do not know if that data is part of it. But knowing Cloudflare and knowing their track record, we have an API for almost everything. I think you will find something. More questions?
What are the alternatives?
Alternatives?
Yeah.
That's honestly a discussion we have right now also a lot. I mean, to be fair, just to comment on that, Angular has done a lot of improvements. So this kind of loading orchestration we have now built, they are now discussing in an RFC. So they kind of have this deferred loading feature where this should be built into the framework. But it's an RFC. We are discussing also with them. We were also having the chance to talk to the team in Salt Lake on the NGConf. So that was quite cool to talk about this. And they are working on it. But changing the framework, look, as I said, we have like 400 components, personalized infrastructures. We have a lot of microservices where we have connection between front end and back end. Switching the framework for us would be a very long journey. So we are kind of, for the moment, hoping that Angular now catches up. It seems like Angular is catching up. But yeah, talking about the competition, looking at Next, for example, you have server-side components. You can write JavaScript code and annotate where it should run on the server or on the client. I know the Angular team is working heavily to achieve the same and will provide it, but for us, sometimes it's kind of sad to be a bit falling behind with Angular 70 standards. Felix first.
Can you recommend any performance measurement best practices for your soft navigations in Angular SPA? Do you have particular components that you kind of watch out for, some custom metrics you find?
We have a few custom.
And could you use that?
Thank you. Yeah, I mean it's kind of tricky, right? Because you have to implement it and you have to say what do you want to measure. To be honest, the way how largest content for paint is measured from Google, I'm not satisfied with because it measures the single biggest element. So in our example, it would be just the text in the teaser. While I would think from a user perspective, especially on our website, even though you don't see the jackpot, for example, it's very nice already to see the visuals of our products. So it's kind of a hard discussion. What specifically do you want to measure and what kind of is the interactive thing? And talking with our product managers, we figured out it even depends on the customer. It depends on the funnel and the journey. If you have a customer coming from a TV campaign and the interest is for the business to convert him to a first-time money player, then another component is relevant for that person to be fast. Then, for example, for a returning customer, it would be maybe the voucher. For the new customer, would it be maybe a special offer or something else? So it's kind of very difficult to agree on that. And yeah, that's still an open question. But what we measured so far is route start, route end, and we kind of waited for the last visible element of the page. That was the implementation so far. I think it's not good enough talking about the funnels, but it's something that showed us that the problems there are much less severe than the problem with the initial loop. Eric, you had a question too.
Yeah, I'm afraid Felix stole my question kind of, but maybe I have a follow-up. So, if you care about all of these different components that they render, and even depending on users, what they are interested in, you would essentially analyze different things. Have you thought about the element timing APIs, where you can essentially get tracking for specific things that render on the page?
Yeah, that's what we are using, for example, to get a route change. So we set the element timing API and call the metric measured on the last element of it. Yeah, so we are looking into those APIs and have some of them also used for tracking. But again, it doesn't help us with the challenge of knowing what is now the most relevant feature for that specific customer in that specific funnel. And that's kind of, we try now a way to figure it out by URL parameters, because we know if someone comes in with a campaign ID, if someone comes in with certain parameters, that most likely will be acquisition, and then other features count. But we haven't found a good way to get this into the code base and, make an easy way for developers to scale that configuration, right? Because at the end, you don't want to know for every feature or component what funnel you are. You just want to annotate, this is now in that scenario the most relevant. Cool. Any questions maybe from the visitors from the net?
A lot of congratulations.
Okay. Thank you a lot for the congrats. Thanks a lot. Cool. Yeah, no more questions. Thanks for having me. I really enjoyed it, and have a nice evening. Thank you.